In the recent crystals video I had a couple of requests for a small follow-up of some description with relation to the original circuit that I used for testing the crystals. There's a couple of things worth pointing out on here that I've done just to make life a bit easier. The first thing is that the cap here is actually in a socket, so I can just easily take that out and replace it with a different value should I need to. The test socket here is actually divided into two halves. So I've got, I think, 8 pins here, four on the left, 4 on the right, and they're for each side of the crystal. So it's actually divided in the middle. With relation to the pot, first time I made this, I was very conscious of trying to keep all the wire lengths the same. But in subsequent revisions, I think this is the third revision maybe, it actually doesn't really make any difference as to the length of the wires or the resistance. Then if we come to the back side, the camera's actually having a bit of a problem focusing on that, but hopefully you can see that I've got jumper links here. Now they are grounding all of the unused inputs on the 7404, which is quite important on the circuit like this. The unused inputs should be grounded to stop any spurious operations actually within the IC itself. And also you can just about see here hopefully that there's a split between the two halves of the test socket. So then if we come to the schematic diagram, we can see the three inverters that are used in the circuit, 1, 2 and number 3. These are connected so that the crystal under test is connected to the input of the first inverter and the output of the second inverter. The output of the first inverter is connected to the input of the second inverter just via the cap C1. We have the potentiometer, so dual potentiometer, which basically goes across the first and second inverters. The output of the second inverter is directly connected to the input of the third one, and then the output of the third inverter is the output that goes to the oscilloscope. We can see that I have grounded all of the unused inputs. So there's 3 unused inverters on the 7404. The inputs, those inverters are grounded. The power goes between pin 7 and 14. That's a 5 volts. One thing that I didn't actually mention in the original video was when I first made this circuit back in the 80s, I didn't have a digital scope. So measuring the frequency was not quite as easy as it is, as you can see in the video. I used to have to measure time of each pulse on the output on the analog scope and then convert that to a frequency, which is obviously not quite as easy as just reading it off of a digital scope. As a heads up for the next video that I'll be releasing, what I'm intending to do is to try to make a device that you can use in conjunction with a multimeter that will enable you to measure a difference between this piece of nickel, this piece of nickel, and possibly various points along this piece of solder or another piece of solder. The idea being as a type of micro ohm meter, but we'll be using a standard multimeter to try to determine that. I want to try and make the device for less than £5, hopefully £2 or £3, but we'll see. I don't know exactly yet. Anyway, keep an eye out for that one. That'll be coming soon. If you haven't already subscribed to the channel, it would be much appreciated if you could go ahead and do that.